Hidden beneath the hazy orange clouds of Saturn's moon Titan lies one of the solar system's most profound mysteries. This distant world feels strangely familiar, yet remains deeply alien and mysterious. For years, Titan's surface remained concealed from view until NASA developed methods to peer through the haze and uncover the moon's true nature. Here's what they discovered. Our first close look at Titan came in 1979, when NASA's Pioneer 11 spacecraft journeyed to Saturn to study the planet and its rings and moons. Titan itself had been known since 1655, when astronomer Christian Huygens first identified it. Titan is enormous, larger than the planet Mercury and significantly wider than Earth's moon. Still, it lies incredibly far away, so when Pioneer 11 approached, scientists were eager to glimpse its surface. Instead, the probe encountered dense orange clouds shrouding the moon completely. What Pioneer did uncover was the composition of that haze, a thick, nitrogen-rich atmosphere, much like Earth's. Another familiar substance was also detected: hydrocarbons. These are molecules made of carbon and hydrogen atoms, commonly used as fuel on Earth. On Titan, methane, a type of hydrocarbon, fills the atmosphere. Why does this matter? Because hydrocarbons are considered building blocks of life. Structures like DNA and proteins rely on carbon-based foundations. Carbohydrates, which include oxygen, could provide energy for living organisms. While oxygen is present on Titan, it's locked away beneath the surface. Pioneer's flyby also measured Titan's gravity, which was surprisingly weak for such a large moon. This suggests Titan isn't very dense and likely isn't made entirely of rock. With low gravity and a thick atmosphere, a person in a wingsuit could soar effortlessly off a cliff, and a flying machine would be an ideal way to explore the landscape. By the early 2000s, technology had advanced enough for a more detailed study. In 2004, the Cassini spacecraft arrived at Saturn. This was a joint mission by NASA, the European Space Agency, and the Italian Space Agency. Cassini carried radar and infrared scanners capable of penetrating Titan's dense atmosphere. Over 13 years, Cassini flew past Titan 127 times, mapping its surface in stunning detail. Titan is unique, the only moon in the solar system with a substantial atmosphere, 4 times denser than Earth's. This creates a reverse greenhouse effect, trapping cold and blocking much of the sun's faint heat. As you descend toward the surface, methane in the air cools, liquefies, and falls as rain onto a landscape of ice as hard as granite. Average surface temperatures hover around -179 degrees C, just above methane's freezing point. This allows for a full hydrologic cycle: evaporation, condensation, and precipitation, but with methane instead of water. The result: rivers, lakes, and seas flow across Titan, making it the only known world besides Earth with stable liquid on its surface. Cassini's team anticipated remarkable discoveries, so they equipped it with a secondary probe, the Huygens lander. In January 2005, Huygens parachuted toward Titan's surface. Its target was the shoreline of what appeared to be a methane lake. The lander was built to handle various terrains and had battery life for about 3 hours of operation. As Huygens descended, it revealed a dark valley flanked by brighter mountain ranges. Closer to the ground, a network of drainage channels carved into the mountainsides came into view, some hundreds of meters wide and kilometers long, formed by methane rainfall runoff. Huygens landed in what seemed a dried-up riverbed, sinking about 12 centimeters into the surface before settling. Looking around, the scene felt uncannily familiar. Smooth, rounded stones, actually water ice as hard as rock, lay scattered on what appeared to be sandy ground. The mud around the lander turned out to be hydrocarbon material, similar to snow with a brittle crust. Heat from the probe's lamp caused visible evaporation, and at one point a droplet of methane dew slid past the camera. Above, the sun appeared small and dim. Midday light on Titan was no brighter than Earth's twilight. Huygens provided incredible insights, but it missed one key element: liquid methane. It landed in a dry riverbed seemingly at the wrong time. So where was the liquid? The answer lies in Titan's climate cycle. On Earth, sunlight drives frequent evaporation and rain. On Titan, with far less solar energy, methane evaporates slowly. Vapor accumulates in thick clouds until eventually releasing in intense downpours, causing flash floods. These rainy periods may be separated by droughts lasting centuries. During Cassini's mission, scientists observed that in the dry season, liquid methane gathered mainly near the North Pole. They identified Ontario Lacus, a methane lake named for its resemblance to Lake Ontario, though about 20% smaller. Despite its size, covering some 15,000 square kilometers, the lake is shallow, averaging between 40 centimeters and 3 meters deep. Its surface is eerily calm, with waves barely reaching 3 millimeters high. Titan also hosts a small ocean at its North Pole called Kraken Mare, nearly as large as Earth's Black Sea. Here, Saturn's gravity creates tides, causing the methane to rise and fall by up to a meter. Though expansive, Kraken Mare is relatively shallow compared to Earth's seas. Beyond lakes and rivers, Titan has active cryovolcanoes. Instead of molten rock, these spew slushy water. How can water remain unfrozen? The slush contains ammonia, which acts as antifreeze. Ammonia, common in the early solar system, lowers the freezing point of water, allowing it to stay liquid beneath the surface. Beneath Titan's icy crust lies a layer of partially frozen slush, and below that, a subsurface ocean of liquid water may envelop the moon's rocky core. Residual heat and ammonia could maintain this hidden sea. With liquid water and abundant hydrocarbons, the ingredients for life are present. Through volcanic activity, these elements could mix, creating conditions where simple, primitive organisms might form. That possibility drives NASA's next mission to Titan, Dragonfly. Scheduled to launch in 2028 and arrive by 2034, this nuclear-powered helicopter drone will fly across Titan's landscape, collecting samples for onboard analysis. Dragonfly aims to uncover the composition of Titan's sandy surface and search for signs of life, offering our best opportunity yet to solve the moon's enduring mysteries. If you enjoyed this journey to one of the solar system's most intriguing worlds, be sure to subscribe for more cosmic explorations. Give this video a like if you found it fascinating, and share it with friends who love uncovering the universe's secrets.